This section examines gearbox operation. In a rear-wheel drive manual transmission, the splines on the input shaft engage with the splines of the clutch-driven plate. With engine rotation and the clutch engaged, the input shaft transfers its motion through the countershaft to rotate the gears on the main shaft. In this neutral condition, the engagement sleeves and hubs splined to the output shaft are stationary. No drive is transmitted to the output. Depressing the clutch pedal removes the engine load from the input. This allows an engagement sleeve to be moved into engagement with the external teeth on the gear selected. This locks the gear to the main shaft. When the clutch is released, the drive is transmitted to the input gears along the countershaft to the gear selected. Since this gear is now locked to the main shaft rotates and transfers the drive to the final drive unit. The speed ratio and the torque transferred depend on which gear is selected. In this 4-speed transmission, first gear, the smallest on the countershaft, meshes with the largest gear on the main shaft to give first gear. This is the lowest forward ratio. The greatest number of turns of the input are required to achieve 1 turn of the output. This also gives the greatest torque multiplication. In second gear, power flow is through the next adjacent gear. The difference in speed between input and output shafts is reduced. Fewer turns of the input are required to give 1 turn of the output, but there is less torque multiplication. When the engagement sleeve for third gear moves into place, drive is transmitted through the meshing gears at an even higher ratio. In fourth gear, the input and output shafts are locked together. This provides a direct drive with a 1-to-1 ratio, with no reduction through the countershaft gears. The input and output shafts turn at the same speed, and therefore there is no torque multiplication. The countershaft gears and their corresponding gears on the main shaft continue to rotate, as the countershaft is constantly in mesh with the input gear, but they do not transmit any drive. With the vehicle in motion, these gears will be turning at different speeds in relation to the main shaft and to the engagement sleeve, which is locked to the main shaft by the spline. When changing gear, their speeds must be synchronized so that the engagement sleeve can move smoothly into engagement.